Hello, so we're having a look at question 1b here, and question 1b was focused on a decision tree, okay? And the specific decision tree that we were having a look at was one related to a zoo. So the zoo was looking to increase its profit, and it was going to have a look at two options. One was to have giant pandas and the other one was to have a reptile house. So just let's make sure we can understand what this decision tree is telling us. So here we see the cost of the giant pandas. So the cost of having the giant pandas would be £300,000 and the cost of the reptile house would be £170,000. Sorry, that's a comma there. So yeah, the reptile house cost £170,000, giant pandas would cost £300,000. Probability of the giant pandas being a success was 0.6 and failure was 0.4. Remember, they always had to add up to 1. What we would see if it was a success, we would see £700,000. If it failed, we'd only see profits rise, an increase in profits of £140,000. Similarly with the reptile house, again, the success and failure must add up to 1. 70% chance of succeeding, 30% chance of failing. If it did fail, only £50,000 would be generated, whereas if it was a success, £600,000 would be generated. So just a quick recap on how to interpret a decision tree. Okay, and then what we're asked to do is we're asked to calculate the net gain. Okay, so let's just recap how we do that. So to calculate the net gain, what you have to do first of all is you have to calculate the expected monetary value. So it's the expected monetary value, and once we've got the expected monetary value, then we minus the cost from that, and that will give us our net gain. So what we would see is we would have success multiplied by the expected return. What you would then do is you would add that with failure multiplied by the return. And obviously that return is related to the failure and the return here is related to the success. And that would give you your expected monetary value. So yeah, so we've just recapped there quite quickly how to calculate the net gain. Obviously net gain is calculated by the expected monetary value minus the cost, giving you net gain. And we've just gone through how to calculate the expected monetary value with success multiplied by the return of the success plus the failure multiplied. So maybe I should be more specific here. So that's the probability of success, and that relates to the return of success. Again, probability of failure, return of failure. Okay, so let's go about calculating the net gain for both of these options. So let's first of all do giant pandas. So if it succeeds, it's going to be, there's a 0.6 chance that it will succeed. So we 0.6, and the return of the success would be 700,000. So we've got that. And then we have, if it was to fail, it's going to be 0.4 multiplied by 140,000. So let's just quickly do those calculations now. 0.6 multiplied by 700,000. That's £420,000. Then we've got 0.4 multiplied by £140,000. That gives us £56,000. What we want to do is we want to therefore add those two together. So if we sum those together, that would give us £476,000 as our expected monetary value. Then all we'd need to do is minus the cost, which was £300,000. And therefore that would leave us with a net gain of £176,000. Okay, so that's the giant panda. So the net gain associated with the giant pandas would be £176,000. All we're going to do is now repeat the process for the reptile house, and then we can work out which option would be best. But we don't actually even need to do that. We're just asked to calculate the net gain. So reptile house. So chance of success with the reptile house 0.7. If we do succeed, the return will be £600,000. Chance of failure is 0.3, and the return on the failure would be £50,000. So let's just do those calculations quite quickly. 0.7 multiplied by 600,000, £420,000. And then we've got 0.3 multiplied by 50,000. That gives us 15,000. So what we want to do is we want to add those together. If we added those together, that would give us an expected monetary value of £435,000. And then what we want to do is we want to minus the cost. So the cost here was £170,000. So if we just did that, so if we did 435 minus 435,000 minus 170,000, therefore our net gain would be £265,000. So we've calculated the net gain for giant pandas at £176,000 and the net gain of the reptile house at £265,000. So obviously the decision that the zoo should take is they should open a reptile house, because the net gain associated with the reptile house is far greater. But the key thing to remember to calculate net gain is it's your expected monetary value minus the cost gives you your net gain. And then the key formula to calculate the expected monetary value: probability of success multiplied by return of success plus the probability of failure multiplied by the return of failure, and that gives you your expected monetary value.